Now you're watching the educational channel on YouTube. By the end of this video, you will be able to figure out the condensed structure formula for C5H12 n-alkane, the molecular formula and condensed formula of this molecule shown, and condensed and bond line formula for 5-isomeric C6H14 alkanes. We are going to cover higher n-alkanes and also the C5H12 isomers in this video. Higher alkanes, n-pentane and n-hexane are n-alkanes. Pent 5 and hex 6. CH3, CH2, 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 and CH3, 1, 2, 3, 4, 5 carbons represent n-pentane. CH3, CH2, 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 CH3 is n-hexane. So what is being repeated in the middle is 3 CH2s. So you can make a condensed formula as CH3, CH2, 3 of them, CH3. Then n-hexane will be CH3, CH2, 4 of them, CH3. As an additional information, in the laboratory in the year of 1985, a really long synthesis has done on ultra long alkane that was CH3 CH2 of 388 CH3 has been done. It's a really long chain. Then let's do the problem that we were talking about. Problem 1. The condensed structure formula for C5H12 n-alkane. So let's first see if it is actually the alkane. Alkane has a formula of CnH2n plus 2. And here we see that n is equal to 28. Then 2n plus 2 is 56 plus 2, which is 58. So we confirm that it is from the N28 alkane. And we want the condensed structural formula. Then if you remember the pattern down here, pentane 5 has 2 end carbons and 3 remaining CH2s. Hexane has 2 end CH3 carbons and 4 CH2 in the middle. So we expect 2 CH3s and CH2 in the middle of some number of CH2s from the 28. So 28 minus 2 end carbons will give you 26. So this number right here will be 26. Therefore, answer is CH3, CH2, 26 of them, CH3. There we have 1, 2, 26, total 28 carbons. So n-alkanes alkanes have a general formula of CH3, CH2, X, CH3, and we call a constitute homologous series of compounds. So a homologous series is one in which successive members differ by a CH2 group. And now let's talk about the bond line formula. This, at the end of each line, is where the carbon is that we abbreviated in this bond line formula. So this actually represents n-pentane. It has 1, 2, 3, 4, 5 carbons, and always we expect to have hydrogens attached to the carbons, and this gets abbreviated or gets into the bond line formula as 1, 2, 3, 4, 5. Then bond line formula for n-hexane will be 1, 2, 3, 4, 5, 6. This is a bond line formula for n-hexane. Then here the problem asks molecular formula and condensed formula of this molecule, and counting the number of carbons 1, 2, 3, 4, 5, 6, 7, 8, 9, it is going to be a nano. I actually meant to draw 2 more lines here, and let's just do with it. This molecule has 9 carbons and will be named no name. And since n, which is the number of carbon, is equal to 9, if you use the formula 2n plus 2, it is going to be 20. So you will see C9H20 as the molecular formula, and CH3, CH2, 7, CH3 will be the condensed formula. To 13, the C5H12 isomers. In the previous video, we talked about isomers, and we specifically will talk about constitutional isomers. That constitutional isomers have different, same molecular formula, but different bonding, different connectivity. That n-pentane, since we have carbon is equal to 5, has a bond line formula of that where isopentane let me actually draw a condensed formula or bond line formula right here. Isopentane looks like this, and you shall see that as isopentane. And now another pentane named neopentane has a structure of that, and that is how the bond line formula look like for neopentane. And we kind of see a butane that has 4 carbons and 1 branched methyl group here. And for neopentane, we see 1, 2, maybe 3 carbons. Well, let me count. This carbon doesn't really matter. 1, 2, 3 carbons and 2 branched methyl groups on this one. Now, let me draw some methyl branched formulas and let's differentiate them if they're actually different. So CH3, CH, CH2, CH3, CH3 is a pentane isomer because we have 1, 2, 3, 4, 5 carbons. CH3, CH2, CH, CH2, CH3, 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 CH2, CH, CH3. So these are all 5 carbon molecules. They're some sort of isomers for pentane. But these 4 molecules actually represent all same isopentane. So we see that this structure and that structure are identical, and if you flip it maybe 180 degrees, this structure and that structure are identical. And if you flip it upside down and right side left, you will also see this structure is equal to that structure. Now the last one is a little tricky, but this is still isopentane. If you simply move this carbon over here, then we will also see that it's still same thing as the rest. So they all represent the same molecule, isopentane. Continuing with the last problem of this video, condensed N bond molecular or bond line formula for 5-isometric C6H14 molecule. If you make this into n-alkane, we'll see n-hexane. So let's talk about all the bond line formulas. Here is 1, 2, 3, 4, 5, 6, n-hexane. We can have a pentane with a branch, methyl branch. And we can also have a pentane and a methyl branch right here. And you can pause the video maybe here at the moment and find out what the other two possibilities would be. Now the other two possibilities are made from a butane each. So here's a butane, and you have a 2-methyl branch here and here, and a butane with a branch here and another branch there. So these are the bond line formulas for 5-isometric C6H14 molecule, and condensed formula be CH3, CH2, 4, CH3, and CH3, 2 of them, CH2, CH2, CH3, and this one wouldn't have any suggested. Because it has a branch. This one, CH3, 3 of them C, CH2, CH3, and CH3, 2, CH, CH, CH3, 2. Or you can also do CH3 and CH.